All right. Good morning, everybody. My name is Peter O'Donnell. I'm the dedicated solutions architect for Capital One. I've been working with Capital One for about a little more than the last 2 years, and they're an extraordinary customer. It's really been a privilege to support them on their journey. This morning, we're going to talk to you about managed directory services in the cloud, how to solve for complex, secure, critical resources using our managed services. And you're going to hear from our Capital One engineers, my friends here, Kuntal Mitra and Kenny Hill, who've been working on deploying at scale and getting to genuine automation to take some of the heavy lifting out of it to be able to deploy managed directory into the VPCs across Capital One. That allows them to integrate with some of our services like RDS SQL Server, provides authentication for Amazon Connect, and also serves as their directory and services authentication for user login across their platform. They've done a lot of really clever work to make this deployable, scalable, and automated to not only meet their kind of technical requirements, but also meet their stakeholders' requirements for security and encryption and authentication across the cloud. So to really get into it and tell you all about how they've delivered the technologies for managed directory in the cloud, let me introduce you to my friend Kenny Hill. Cheers.
How you guys doing? My name is Kenny Hill. I'm with Capital One. I'm in the Identity and Access Management organization. I lead a team of directory services engineers. I've been doing identity and directory type work for near 20 years. My main focus is moving directories into the cloud, specifically AWS and privileged access management. Today we're going to touch on a little bit of both of those.
Good morning, everyone. Hope you all had a great start to reInvent. My name is Kuntal Mitra. I work on the public cloud engineering team at Capital One. And my main area of focus is cloud security and automation. Handing it back to Kenny.
Can we get slides? We haven't. It worked before. I know. So are your notes here?
Yeah.
You don't have.
No. Yeah.
That's great. Bradley did the first one.
Technical.
I'll get started from here and we'll kick the slides going. So we had a need in Capital One to utilize RDS SQL databases, and we have many AWS accounts and with multiple VPCs. We want to use for identity access management best practices our Active Directory groups. This gives us the ability to use our central provisioning system if somebody was to leave the company, to remove their rights via provisioning. If someone switched roles, our provisioning system takes care of it. In order to do this for RDS SQL, you need to have Active Directory or AWS Microsoft Active Directory. Our first initial response was, go ahead, we've put domain controllers in AWS. We're hosting them on EC2, go ahead and join them. but that's not how it works, and we understand. So RDS runs on AWS managed EC2s. And if they were to join our corporate domain, policies would apply, domain admins would be added, domain users, and Amazon couldn't offer their awesome, I think, almost 100% uptime for that. So you utilize AWS Microsoft AD, which also the EC2s are managed by Amazon. And you guys working off the slides here? It's so we determined that first we started building a handful of the AWS managed ADs ourselves. We worked through all the nuances of getting everything figured out, tweaked to our environment. And that's a little bit about what we're going to talk about today. We started meeting with our cloud team, and Kuntal's on our cloud team, and our first response was, hey, we can automate this, go ahead and we've automated building domain controllers and Active Directory. We can automate building out the AWS Microsoft AD. Amazon offers all kinds of APIs, the multiple languages, and we were going to try to use PowerShell. So we met with our cloud team and we said, hey, we're going to need you to give us IAM access into all of our lines of business accounts and to build directory services. They said no problem, that was okay. And then we said we also need the ability to modify security groups. When you spin up an AWS Microsoft AD, it automatically creates a security group. And what that security group does is so you define two subnets, and then it's going to kind of combine the two subnets and create rules in between those. Those don't actually communicate, though, with your enterprise directory. Okay, but now we have some slides. Awesome. Feel a little bit better. So our cloud team said, no, we're not going to give you rights to manage the security groups. And that makes sense, and we understand it. So security groups, we treat them at Capital One as an application firewall barrier. So we ensure that applications can only ingress, egress, communicate with exactly what they need to. So giving out these rights would kind of be like cloud team giving out one of their keys to their castle. And so we did our next meeting a week later to figure out how we were going to deploy across all of our VPCs. And the cloud team said, hey, we can automate this for you guys, just you need to give us the ability to create incoming trusts. And our answer was no. And not because they said no the week before. It was as far as identity access management, we need to be able to understand exactly where all users, all groups are going to be used for auditing. Being a financial institute, we're heavily regulated. We go through lots of audits, and so we need to be able to find. And you're not going to actually know exactly where a group's used unless you do the audit, but at least knowing, needle in a haystack, which field are you going to look in for it? And don't get me wrong, I started picturing some agile names of directories and how I was going to explain to my boss how we had maybe Fuzzy Bunny trusting our enterprise directory. So the big question we had is, how do we create, secure, and administer AWS Microsoft Active Directory given the segregation of duties? So we have the Active Directory account where we currently host AD domain controllers. This is where it's very secure, and this is where we have our enterprise domain controllers running on EC2. We then have a secure public cloud account, and this is where our cloud team manages most of their automation, and then we have all of our lines of business accounts. Lines of business accounts, this is where we were going to deploy RDS SQL, and this is where we need to build the AWS managed ADs. So our experience building out a few of these manually, the deployments were going to be pretty complex. So there were lots of little things that we had to tweak and modify to make them work. We also knew we needed to fully automate it. So Amazon offers snapshots, so you can restore the directory. But on top of that, we want additional insurance. So part of our disaster recovery plan is we'd to spin up another directory if we absolutely had to. And we tested out migrating RDS SQL databases from one directory to another, and it's pretty seamless. It only takes a few minutes. You can easily change them, and then even all the groups and users stay in. So we worked with Amazon, our AWS account team, the directory service team, figure out how we were going to do this. And we came up with an approach of using IAM roles and Lambda step functions. So we'd start with an EC2 instance sitting in the AWS AD account. We'd have the step functions and a few other Lambda functions sitting in the public cloud account, and then we'd build the AWS managed ADs in the lines of business accounts. We'd spin up the EC2, and that would have the automation that goes ahead and initiates the build. This would assume a role in the cloud account. Kuntal will get into more details on exactly how that works. Though that role only has right to run the step functions or the Lambda functions, and then the step functions themselves have assume another role into the line of business account that's able to build the directory and do a few other things. So back to that, no, you can't modify security groups. This is how we get around that. So we'd first call the step functions, and they'd go through a list of different things that we're able to do all in one step, and Kuntal's going to go into more details. With this configuration, this allowed the cloud team to know that they weren't giving out too many rights. Everything's secure, and it allows the directory services team to build when and where they need to, following their naming standards, ensuring we're auditing those directories. There's an additional challenge, though. So we have, with VPC pairing and some of the limitations, we need to be able to discover the directory, and we're utilizing, if you follow the document that Amazon has posted, it's going to tell you to utilize conditional forwarders, and that's one approach, and that works great. For us, the number of directories that we were building, it wasn't really feasible to use conditional forwarders, and it also added in another step of segregation of duties. We'd have our whole network team we would need to deal with. So we are creating our records in Route 53 for the AWS managed AD. So there's a handful of A records and SRV records that you need to create. It's key to have the records, or you're not going to be able to build the trust. And so this is how we got around using conditional forwarders. But the first thing we need to do is we need to discover the directory from our AD account. So we have a read-only role that allows us access to directories inside the lines of business accounts. We go and we discover the directory, and then we can do whatever you want to call it, NS lookup, dig, get DNS host name. We have to get the actual names of the domain controllers that were spun up for AWS managed AD. And depending on if we're going to prod or a dev or QA downstream, we may build more. So Amazon released an awesome feature a handful of months ago. Originally, it was you could have 2 domain controllers. Now, I think it's a soft limit of up to 20. So if you want more resiliency, you can throw 5, 10 at it. For this step, we'd have to repeat it multiple times. We then call using the same role we had, another Lambda function that goes ahead and creates the Route 53 records. Now that the records are created, we're able to resolve the directory. So we're able to, on our enterprise directories, we're able to determine, we can see the directory, you can build a forest trust. So we build one-way incoming forest trust. Next, we'd call another Lambda function in the public cloud, or our cloud secure account, which builds a trust. This is where you pass your DNS, your DNS server names also. Finally, we then need to rename the default site. I'll go into more details in a bit after Kuntal talks on why we're renaming the default site. And we then configure groups, also talk a little more about that, and then validate. So, with this, I'd like to allow Kuntal to talk for a little while and explain more on the automation, exactly how all this, nuts and bolts of how this works.
Sure. Thanks, Kenny. So as Kenny explained, we have automated our entire directory services setup process to a single click of a button. So let's go through the details and see how we achieve this end-to-end automation using serverless architecture wherever possible. Now, the first step in the process is basically we have a PowerShell script deployed in an AWS account, which our Active Directory administrators can remotely invoke. So once the PowerShell script is invoked by our administrators, it then assumes a role in a secure AWS account, which then triggers AWS step function, which initiates the entire setup process. One of the reasons we went ahead with step functions is it allows us to create complex business workflows by dividing functionalities into steps and utilizing wait conditions, decision branching, and exception handling to implement long-running processes. Now, one of the most important things to note here is the usage of assume role and deployment of your cloud automation tools in a secure AWS account. It not only helps us to achieve segregation of duties, but it also helps us to secure our automation workloads and our cloud infrastructure. The PowerShell script internally uses AWS instance profiles. As you know, in order to invoke AWS APIs, we need credentials. So PowerShell script is tied to an AWS instance profile, which then generates temporary credentials. And then you can use those credentials to invoke AWS APIs. Now, in order to create and configure AWS managed Microsoft Active Directory, as we have seen that the PowerShell script assumes a role in a secure AWS account, and then it starts the execution of a step function. This step function handles all the complex workflows involved in setting up the directory services. Like, for example, creating AWS managed Microsoft Active Directory, configuring monitoring. It's really important to monitor your directories and to notify stakeholders as and when your directory domain controllers are down or your directory services start acting up. Next, we need to discover and update our security groups. The default security groups created by AWS might not work in your environment, as you might have some different network configuration. So it's really important to discover and update all the relevant security groups to make sure that you enable inbound, outbound traffic connections to establish connectivity. Next is to increase the domain controllers. Now, it's really important for your production workloads to be highly available and reliable. So it's really important to figure out what your volume constraints are, and based on that, you can update your domain controllers. Last but not the least is to create Route 53 record sets. Now, this record set is really required for establishing two-way trust relationship between the AWS managed Active Directory and your organization's Active Directory. We'll see in a bit why that trust relationship is really important. And just to mention, it's really easy to automate the entire process because there are a number of AWS APIs available out there, and you can use any programming language you want. So that really makes it easy to automate stuff. Now, once we have this Active Directories set up, we need to discover those directories and figure out the number of domain controllers that are attached to those directories. Now, why do we need to figure it out? Because once the domain controllers are created, they'll be assigned an IP, and based on the IP, we need to figure out the host name associated with it. The host name is required for setting up this trust, creating Route 53 record sets. So what our PowerShell script does is it again assumes another role. This time it assumes a role in every LOB account to gather domain controller IPs. Once we have the list of IPs, our PowerShell script will perform some basic operations like resolve DNS name to capture host names. Now, again, one important thing to note here is your PowerShell script should really be deployed in a VPC, which is peered to every other VPC where your directory exists. The reason being, you need to, in order to perform DNS resolution, you will need connectivity. And unless your VPCs are peered, you won't be able to resolve those entries. Next, with these details in hand, our PowerShell script will once again will assume another role, this time in a secured AWS account, and invoke a Lambda function, which helps us to set up all the Route 53 record sets. Now, next is to set up the trust relationship. As I mentioned earlier, the trust relationship is really important. And in order to set up the trust relationship, we need to create an incoming trust as well as an outgoing trust between the AWS managed Active Directory and your organization's Active Directory. Now, the trust from from AWS managed Active Directory to your organization's Active Directory is really important because it's the one that will allow you to use single sign-on authentication for RDS SQL instances by tying it back to your primary domain, which is there on your organization. So you can use your internal users and groups to grant access or deny access or modify access as and when people change different work streams or new people get hired or existing people leave the organization. And again, all of these like cross-account, assume role functionality, AWS step functions, Lambda provides us a powerful way to organize and deploy your automation tools in such a way that you don't have to maintain multiple copies of it. You can just deploy in one account and then execute across multiple accounts to set up your directory services. Now, at this stage, your directory services is completely set up. It has all the basic requirements which are needed for it to be functional. But there are a couple of steps which are needed in order to optimize the administration of this directory services. So I'm going to hand it back to Kenny for him to finish describing the final steps in the process.
Good job. Thanks. So I'm going to rewind a little bit. Got a little shuffle with the slides. How many guys are using AWS managed AD today? How many guys are running domain controllers on EC2? OK. So good mix, probably more running EC2. We're going to have time for questions at the end. Feel free to throw any of the questions on either to us. There's also a session, couple sessions on AWS managed or AWS Microsoft Active Directory that Ron up here is presenting at. All right. So rename default site any of you who are used to managing large enterprise directories, multiple forests, even resource domains, you probably know about Microsoft best practice to ensure that your AD sites are the same to tell where traffic should go. So for us, at the scale we're operating with this, it's absolutely critical for us to keep any authentication, authorization, which is occurring to AWS managed AD, going to domain controllers that we have hosted in AWS. If we lost direct connect, this would still, our traffic would stay up there. It's the same thing. We're domain joining both Linux and Windows instances to our enterprise directory, and it's absolutely critical that we keep that traffic, especially for an application that's going to need to scale to stay. So having the site names the same is very important for us. On top of that, I'm going to explain more why. We have multiple VPCs where our enterprise domain controllers are hosted. There's currently a 125 limit peering between VPCs, but a route table limit and heavy recommendation not to increase by Amazon of 100. So essentially, you can have 100 VPCs peered to each other. So in our AD account, once you hit 100, what do? You either stop domain joining or you build another VPC with domain controllers. You hit another 100, you build another one. So that's where we're at. We have over a handful of different VPCs where we have domain controllers, no specific order. It could be anywhere. So it's really important for us to first know. So as a new AWS account, excuse me, or VPC is created by our cloud team, Active Directory is part of that loop. A subnet is created for the CIDR block of the VPC, and it's assigned to the AD site where the two peers are. So in part of our managed AD rollout, we have to use that read-only line of business account, go into and discover the VPC and get the CIDR block, more importantly. So if you use the /16, 14, whatever you guys have for the IP range assigned to your VPCs. Once we have that, we can then do a PowerShell command to discover which AD site it's assigned to. And that's where Kuntal was talking about. It's important to run the automation in somewhere where you have network connectivity. So if we have multiple VPCs, we know ahead of time before we spin up that EC2 that's going to do this work, we know that it's coming from one of the AD VPCs, which is peered. Once we discover that the subnet, then we can just use a regular AD object, rename command to rename the site to match. At this point in time, any authentication that comes to, say, an RDS database will go to AWS managed AD and then stay to domain controllers that are hosted in AWS. Of course, if those were down, it would go elsewhere, chase referrals, but the idea is to keep all the traffic there. The next part, and again, I think this is really the case for any company, not just a regulated financial institute, is you need to be able to audit your domains. So at this point, and manage them. At this point where then the trust was built, we're able to utilize the AWS managed AD, but we need to ensure we're able to discover anything in there. Today, our use case is really light. It's RDS. We may utilize it for more future. So we want to make sure nothing extra is showing up in the directories that's not auto-created by RDS. So At this point, we add a few audit groups, which have service accounts that are going to constantly check what's in the domain and report on it. It has some alerting that go off if something's created and it shouldn't be. And we also want to be able to manage it. We don't, the whole premise behind doing this is so we're not managing local database accounts for RDS. It's to utilize our enterprise directory, and the same concept goes for managing these directories. Is we want to ensure that our admins can use their privileged account, which we rotate the passwords every few hours on, versus using a stagnant account that's sitting in the directory. So this is where we add admin accounts and audit groups. Then we need to validate that everything's healthy with the domain. So we have a list of PowerShell commands there. We're getting the domain controller list, and this is the trigger that tells us as far as when the report comes back or we're going to audit it. If we said build 5 domain controllers and only 3 show up in the report, someone needs to go take a look and see what's going on. We also are checking the trust, and this one's cool because this is going to tell you if it failed. And my tip here is, out of all this automation, we've run it a few hundred times, the trust part has been where we've seen the most failures. And this is due to even though we have the site renamed already, but when we call the AWS API to build the trust, it could chase referrals. So that means, by chase referrals, I mean it's, if you guys aren't too familiar with DNS, it's going to pull back the list of DNS records and say, it's going to start at the very first one. If you say you have your multiple regions and you don't have access, or you have firewalls, or security groups aren't set up right, then the outgoing trust will fail. And it doesn't fail that much. I think we're at about an 85% success rate, 15%, but it's always been where if we run it a couple more times, then it will be successful. So you delete the outgoing trust, you recreate it, and it's successful. Or we ended up having a firewall in the way. The next one is we're just doing a get directory. This allows us to log and send off the notification of the directory ID and all the important information. We then check the trust and validate that our incoming trust is good. So we are building, for our production, we have a single trust, but for our dev and QA environments, we have multiple trusts. So we think you can build more of these, and sometimes you'll see where one's successful, one's not, and it's almost always network related. So that's really it, guys.